Yes. All right. So we're going to graph basic functions. And you're looking now at, here's your function, your first function, f of x equals sine of x. Here's cosine function, f of x equals cosine of x. These two pictures are considered parents. Parent functions of these two trig functions. What does it mean to be parent?
Like, I would usually assume it's default, like y equals x squared, and y equals...
It's your most basic sine and cosine graph. There's no shifting left and right, no shifting up or down. It's sort of right there in the middle of the curve. You know, 0, 0 should be somewhere like in the center of the whole picture of all of those parents. Is 0, 0 tends to be either in the middle or on the graph, like square root curves, 0, 0 happens to be at the left end. But most of them, they're in the middle. And I wanted to show you some things here. If I just talk about the sine curve, well, before I talk about it, if I take the first curve and I shift it to the left a little bit, could you imagine that this point could eventually be right here? Right here?
Yep.
And if that point became right there, wouldn't that also make all the other points shift left?
Yes.
So then it would look something like this. And like that. And what I should have done a different color. If it shifts, it all will look like that. Well, of course, that piece isn't there no more because I just shifted that. You see how it would look just like this piece right here? If I shifted that one to the left, it would look like that. But that's another day, I said. All right, let's look at some things that are in common. This curve goes as high as this y value. Oh, I missed it. I can't even draw a straight line. There. Close enough. That's close straight. How high do you think it went? With one tick mark.
I don't know, 1.
Ah, very good. That's 1. How low do you think this one went?
-1.
Yeah, exactly. From -1 to 1. That's the range of this sine curve. By the way, look at the tick marks on the x-axis. Make sure your calculators are in radian mode because today is radians, okay? See the pi and the 2 pi?
That's why the graphs look...
Oh, yeah, you've tried graphing one with your calculator and you were in degree mode. So when you do a degree mode in your calculator, you have to go to Zoom Fit. I'm sorry, Zoom Trig, or you will never see the shape. It'll look really weird.
It's at 84, it just shows you it.
Well, hit Zoom Trig and it'll look fine.
Does it look better? Or?
Yes. But if you're in radians, I still do Zoom Trig if you're in the 84. Now, look at here. This curve repeats itself. See how the picture starts here at the 0 on the x-axis at the height of 0? It goes up, hits that height of 1. It goes down, hits the height of a -1, goes back up. And if I stop right here, wouldn't you agree that the left piece looks exactly like the right piece?
Which one?
The blue
The blue.
looks identical to the red.
Yes.
It's because they repeat themselves, and we call that the distance that it started until it ended, that distance, we call that the period. How long did it take starting here to start replicating itself? That's called the period. And you know what? That period, a length of time, is the same as the red. It's called the period. How long it takes to finish a whole curve. Or some authors call it, this is one cycle. This is another cycle.
Also, after it makes a full, like, up, down, and back up thing.
Right. It's a cycle. And so these functions are called periodic because they repeat themselves. What else can I say about this sine curve? I talked about it has a period, and the period looks to me like, here's how I calculate the period. Started at 0 here, stopped at 2 pi. So what's the length of that? From 0 to 2 pi.
From 0 to 2 pi, what's the length?
Yeah, how long, how much, picture it time, like 0 o'clock to 2 pi o'clock. How much time went by?
2 pi.
2 pi. Nice. And by the way, guys, it's 2 pi on the left also because this was a negative 2 pi and this is a 0. So if I take 0 minus the negative 2 pi, guess what that turns into? 0 minus 2 pi is how much?
2 pi.
2 pi. Every cycle will start and finish with 2 pi radians. Isn't that exciting?
All cycles will finish with 2 pi.
2 pi for the basic parent. Here's a parent of cosine. If you looked at this part in red, watch me. If I graph it from there and I stop here, it looks like I graphed a sine curve, doesn't it? Looks just like that over there, right?
Yeah.
But because it's shifted, the way it's shifted, I'm not looking at what's in red. I'm looking at what is starting from here at the 0. Again, the x is 0. Whereas the sine curve starts at 0, 0. The cosine curve, a positive cosine curve, starts at the very max. And how high did that go, did we say before? It's a 1. And then it goes as far down as a negative 1. So a cosine curve, I like to say, starts either at the top or at the bottom if it was a negative. You'll find out later. But if you start up here, then it goes all the way down, touches the minimum, and goes all the way back up. It makes this beautiful curve. And guess how long it takes to start to finish? What's the period? 2 pi again. Right.
Oh, so for cosine, we go like that?
This is that is one way of looking at cosine. Some textbooks want to look at cosine starting at negative pi, all the way to pi. Some textbooks want you to look at that picture. That's okay, because it's still a 2 pi. It's still a 2 pi period because you add pi this way and pi this way, it's still 2 pi. But some books want to draw cosine looking like that. It technically is more correct in another sense, but I don't want to overkill you with details. It has to do with the unit circle, you know.
Oh, no.
Yeah. Guess here I'm going to bore you with details. The unit circle could help us with these graphs because remember what we talked about, these ordered pairs, 1, 0. I think I gave you guys a cheat sheet with it, right? 0, 1, negative 1, 0, 0, negative 1. If you go to 0 radians, that's this part right, starting right here. 0 radians uses this point right here. And I want to remind you guys that I told you that when you look at your unit circle, the x and the y, that the first number x stands for the answer to cosine, remember? And the second number y stands for your answer to the sine. So if I asked you, what's the sine of 0 based on this ordered pair at 0? Sine of 0. This is 0 degrees right here.
1? No.
It should still be 0.
It is 0 because the ordered pair is 1, 0, and the y value is your sine. Well, look over here at your graph. Where was the graph at 0? 0. Where's the graph at pi? Pi is where on the unit circle? How big is pi?
180.
180. That's over here. There's pi. That ordered pair is 1, 0. What's the sine of 180 or pi?
Wait, negative 1, 0, and
What's the sine value?
sine value.
Of
270? No.
of pi. What is the sine of pi?
Wasn't this on the...
You had it on your test before the last test.
It's still 0.
It's still 0. Yeah, the y value. Well, look at the curve. Where am I at pi?
I was just done.
I'm at 0.
Huh. Okay.
How about pi over 2? Where's pi over 2 at? It's between 0 and pi. Isn't that right here? Wouldn't pi over 2 be here?
Oh, pi over 2, not 2 pi.
Yeah, pi over 2. What's the value of the height now?
1.
Let's see if it matches up with my unit circle. Where's pi at?
180.
No.
Oh, no.
I'm sorry, where's pi over 2 at?
Pi over 2, that's 45 degrees?
No.
Pi over 2 is
Not
90.
90.
That's this 90 degrees, so I'm at this ordered pair. What's the sign there?
0, comma what?
What's the sign?
Oh, sine.
1.
1. Didn't we say it's at the top?
Huh.
So this matches up to the unit circle. Cosine does the same thing. Look here at pi. Cosine of pi. What does it look like the answer is?
For 1 pi?
Cosine of 1 pi.
Negative 1?
Does it look like it's there at negative 1?
Yep.
Okay, let's look over here.
Oh, that's cool.
Cosine of pi. Pi is over here again, right?
Yep.
What's the x value?
Negative 1.
Negative 1.
Oh.
So it matches. Those things that we learned before match. Okay, let's move on here. Note, I already said this to you. Note that the cosine function is the, what's the word you got there? I don't have my glasses on. Shame on me. Is the
S-O-L.
horizontal translation of the sine function. They're telling you that the cosine function, this one right here, is actually the sine function after you move it. Well, you can move either one. Sure, you move the sine function to the left, it becomes the cosine function. Move the sine function to the left, it can look like the cosine function. What else did they say? Any transformation of the sine function is called a sinusoid. Sinusoid because sines and cosines can mimic each other. Sine can become a cosine equation. You can take a cosine equation and turn it into a sine equation. They're called sinusoids. That's why they're both called sinusoidal functions. I call them periodic functions. That's also true. Any function that repeats itself is periodic. Okay? Now, he says it too. She says it, periodic. Let's do the definitions of period. A period is, I want to say,
Repeating segment?
how many radians, or if we're in degree mode, we could talk about degrees. How many radians to graph one complete cycle?
Oh no, this is physics. I just realized that's wavelength and amplitude.
Oh, absolutely. Absolutely. You're going to see it involved. You're right. So we said that the sine curve completed it in pi, remember? Or 2 pi? Hello? 2 pi to finish the graph? Or over here, 2 pi to finish the graph? That was called the period. And there's actually a symbol for it. It's this fancy T called tau. So you can say tau could be 2 pi. It could be, but T-A-O, I think, is the Greek symbol, but rhymes with cow, which is C-O-W, but they're not spelled the same because T-O-W is tow, like a tow truck. All right. We'll get to the formula in a minute for the actual formula for a period. Amplitude, what do you think of amplitude?
Up and down.
Oh,
How many times it goes up or no, is it?
you're thinking of frequency.
Oh, yeah.
Oh, that's sweet.
Amplitude is when you're standing next to a train coming and you hear, what happened? As it got closer to you,
It got louder.
it got louder. That's because the frequency changed. It's hitting your eardrum faster than it was when it was farther down the road. So when I talk about amplitude, you can turn up the amplitude of your speakers And that means more volume. So amplitude is actually, it's 1/2 the distance of your maximum is how high you go, to the minimum. 1/2 the distance. If I go back to my sine curve, guys, here's the distance between the max and the min. You told me it was 1 and a -1, remember? So what's that distance?
2?
2. What's half of that?
1.
So your amplitude must be this distance here, or this distance here. Now I don't care, this is -1 distance, right? And this is a +1, but we always talk about the absolute value,
So there's never negative.
never negative.
Amplitude would be something, it's like a simple way to get it, just go from the top to the middle.
Exactly, that's actually the easiest to do, if you can find the middle. And it's usually pretty easy to find the middle of a sine
You
curve.
use, like absolute, or not absolute, but you can just like see how far it goes up, and then that's just your amplitude.
You can. Start at the middle of the curve, see how far you go up. And don't worry about the -1, right? Yes. 1/2 the distance of your, of your
Maximum to minimum.
max to min. Yeah, 1/2 that distance of, I don't know why I put your, it's not yours, it's mine. Of max to min. It's that distance there. Now, since the parent functions are kind of basic, guys. Why are they parent? You got y equals to 1 times sine of 1 times x. That's your parent. Whoever writes it like that? Nobody does. We write it as sine of x, right? Same thing with your cosine. You can write y equals to 1 times your cosine of 1 times x. Most people just write cosine of x. But it doesn't have to have ones. Look at here. This is actually the equation for a basic graph.
That's it?
It's still basic because you haven't moved it left or right or up or down. But there could be a number in front, and there could be a number, and I tend to be careful here, is that this b, there's really parentheses around it
Why does
on
it
your
have to make it
calculator.
so complicated?
I don't know.
Like, it's just sine of x. Like, the number could be either inside the parentheses or outside the parentheses.
Well,
In front of sine, how much?
in front of sine, yes. Inside the sine, if you choose to do this, like y equals to 2 sine, and you say 3 in front of the x, you're not exactly wrong, but you know what you're really missing? That you don't realize it? There's no way to key that in your calculator like this. You'd be forced to have to write another parenthesis on the outside and inside.
Like that.
Yeah, you would have to have the sign of something. This whole thing needs to be in the parentheses, okay? So same thing here. We got an A and we got a B. And that really is that's the whole, the X is the angle. X is the angle, X is changing. B is a number in front of it. And so let's define this. The amplitude is I'm going to put absolute value of A, just in case you don't listen to what Adam said. Adam said, why worry about a negative? Just figure out how high does it go from the middle up.
It should mirror the bottom.
Yeah, there should be a mirror image. So this is my A, but if I had the opposite down here, this would be the absolute value of A would still be your amplitude.
Just to check, we're never gonna have a situation that where one part is higher or lower than the other.
No, because the middle is the dividing, cuts it in half.
Hopefully, mathematically not possible.
There is such a sine curve that is that way. It's called a dampening oscillation. I'll give you an example. A spring. When a spring bounces, at first, it looks like it repeats itself, right? But what happens is gravity tends to get involved. You see? So you get the sine curve, way high, way low, way high. Then it starts high, low, high, low, high, low, high, low, high, low until it levels off, right? So it's called dampening. So that's where you get some weird things happening, but that's in applications. But we won't be doing that, okay? But you might in physics.
I'm already done with that.
Oh, okay. The period, I'm going to give you that symbol. I know what you're thinking. If the amplitude is A, the period must be, but it's not. There's a formula. It's 2 pi divided by the B. But I never want B to be negative. So just in case, sometimes they put the absolute value symbol with it.
That's a good idea.
But I never write that. I always just go 2 pi divided by B. Now what does that mean? Why is it 2 pi divided by B? Because what we want to say, if you go to your parent up here, say it again. This one ended at 2 pi. And how many graphs did I make from 0 to there? You actually hit it on the head there, Emma. If you look at how many graphs did I make from 0 to 2 pi, how many cycles should I say? No, from 0 though. From 0 to 2 pi. Yeah, it's only one.
Is that a whole cycle?
That's a cycle. Yeah, so if we go to 0 to 2 pi or all the way to take 2 pi, I say, how many cycles are there? 1.
And the other one wouldn't count.
Well, that's another cycle. You're not, so what we're asking is, how many pictures can be drawn from 0 to 2 pi? And
I was asking, the other one doesn't start from 0 to 2 pi, right? It starts from the -2 pi.
negative 2 pi to 0.
Wouldn't count as a 0 to 2 pi.
No, but you could say, how many pictures can you make from negative 2 pi to 0?
Yeah.
Still 1, right?
Yeah, that's what I said.
And you're saying, well, doesn't it always 1? No. If you change your frequency, if you change the period, you literally could say that I actually got a picture here and then another picture here. I got 2 of them in there. How many was drawn within 0 to 2 pi? 2 pictures. Or you're going to see where we get really lazy. We get really lazy, and all I draw was, because I'm so tired, let me erase all that. Erase it. Okay? Instead of this, I go, I'm going to do an atom. Oopsie, I only got a half a picture. The other half is over here outside of 2 pi. You know, I'm saying squeeze them in or stretch them out. That changes your period, because if you squeeze it in, the period is more because you get more pictures squeezed together. But if I stretch it out, I get less. I only get a half of a picture, half of a cycle.
That's not good.
All right, so let's see if we can use this. Let's see who's listening. And this is a good lesson, but you guys have been promoted to advanced math. Finally, advanced math. This is advanced. This is not baby stuff.
Oh, hey.
Can we go back to baby stuff?
No, you guys did worse on the baby stuff. You know the last test? I got more hundreds from all 4 classes than I've done on anything else.
Well, I mean, it wasn't that easy. What?
You know, they just have a natural thing to triangles, I guess.
Trig is just, there's something about humans and triangles. It just makes sense.
Geometry.
Oh, could be.
Also, in the previous lesson, you said like the number inside of the sign cannot be greater than 1 or less than.
To do the inverse,
And
yes.
When you look at these graphs, that's 1 to -1. You can't just.
Oh my gosh, you hit it on the head.
So you're saying that it can never go up past 1.
Well, we were doing like inverse sine and inverse cosine, right?
Right.
And so if you look at that graph, inverse means what's the angle that gives me a height of 1? What's the angle that gives me a height of -1? What's the height that gives me the height of a half? In other words, arc sine of 0.5. Arc sine of 7 out of 9, which would be up here. So then you're finding the trig values that you could get, but you're right, there's nothing outside of that. Good Good catch, Jonathan. All right. Here's a basic graph. Help yourself out. What does the A number look like?
A number?
Yeah, the A number.
1.
1.
It's right there. It's invisible. Nice. What does the B number look like? 4.
Yes, the coefficient of x.
That's right. The coefficient inside there. You're right. So when I ask you for the amplitude,
It's 1.
it's still 1?
I just.
Is it really?
Well, I just did the calculator. It's still-
Cheater, cheater. You graphed it? Thank you very much. I need people to graph them. I want you to see the graphs compared to our answers. So Adam graphed it, and he said, obviously, the amplitude is 1. I want you to also realize, though, Adam, that there was a 1 in front, so you know it had to go up 1 and down 1, so therefore the amplitude is 1. So
let's see on number 2, the amplitude is 7/2. Is that just that?
absolutely. And if you go to your graph, you'll see that if you trace your graph to the very top, you will see the y value is 3.5.
Nice.
All right, now, period. Got to use my fancy formula.
Oh, God.
2 pi
Absolutely.
divided by the absolute value of b. In this case, what is 2 pi? Divided by what?
It should just be 1/2 pi.
2 pi divided by what?
4.
4. That turns to,
1/2 pi.
or pi over 2.
Or pi over 2.
Which, when Adam graphs this with his calculator, and I hope the rest of you do, how many calculators are out? Not that many. Most of you aren't carrying, unless you have your own calculators. If you graph this one, let me graph.
I got 1.57.
Oh, where? Where are you at? On number 2?
Okay, no, number 1.
Oh, yes. Pi divided by 2 is 1.57 something. Yeah, exactly. You will notice that the first one finished at 1.57, right?
I thought it was 2 pi over 4.
It is. That reduces to pi over 2,
Oh.
which is 1.57.
I mean, yeah, I think if you just graph it, you can just go to the first, after the first period, and then you can just have it.
Absolutely.
Oh, nice.
Natalie? Is that Natalie back there? You okay? Oh, I thought you fell asleep or passed out. All I saw was, I saw pink hair. All right, next one. What's the small a?
7/2.
What's the small b?
1.
1. So what's the amplitude?
7/2.
We don't. It doesn't matter, right? What's my period?
2 pi over 1.
Which is?
2 pi.
So if we graph the parent cosine with this one, shouldn't they start and finish at the same place? Well, let's graph them both in our calculator and see what we get.
Would this one be on this? I would have died 100%.
Well, somebody's going to get it. All right, number 3. What's the, you want to jump right to the amplitude? Tell me the amplitude.
Amp is negative, no, 5, just 5.
Why is it just 5?
Absolute value of A.
It was the absolute value of a negative 5, which is 5. Absolutely. And then my period, which I label as tau, would be, oh, okay, I can tell you're going to have trouble with this because you guys don't like fractions.
I could plug in fractions and fractions and fractions and fractions all the way. Like.
Okay, all right. I want everybody to think. Said, don't yell out, Jonathan. What do I write down? 2 pi divided by what? I can't hear you.
Sure.
You have a secret?
Yeah, she does.
Can I hear it?
Maya just say it.
Say it, Maya. Hey, I'd rather you be wrong and trying than to be right never because you're not trying.
You got this.
Is it 2 pi over 3?
It's 2 pi over 1/3. So, unfortunately, there are people in here who don't know how to calculate that. So let me give you a secret.
I would have, what's it called? I was already.
If you do 1 divided by 3.
Cosine of 1/3 and then putting it under the 2 pi.
You're going to do the cosine of what?
1/3 and then putting it under the 2 pi.
No, that won't be good. Cosine of 1/3 is just a value, a number.
I got a 2 pi over 1 divided by 3 in parentheses and that'll work.
Guys, treat it as a number divided by a fraction. Since we hate fractions, let's turn it into the number times the reciprocal. We flip the bottom fraction.
That turns into a 3.
turns into a 3 over
1, which is a third.
3 over 1, or a 3. Think of it as 2/3, 2 pi times 3. And what does that turn into?
18, wait, which one?
2 pi times 3.
Oh.
All right, division of a small number.
What's 2 times 3?
18.84.
No, I want the exact answer on my paper. I want the exact answer, no decimals rounded.
19.
Where do you guys?
What?
6 pi.
6 pi, thank you, that's
Where do
the
you guys get
exact.
18 from?
6 times 3.14 will be approximately 18 point what?
Oh,
18.845 or 85. I guess.
But I don't want that answer.
because I thought people were doing like 3 times 2 is 18. or
Well,
something.
I knew where it was coming from because I saw him on his calculator. But the exact answer is 6 pi, and I'm glad you said it's 18. So if we go to our calculator and graph this bad boy, we're going to see that since 1/3 is in front, you know what this means in English? Only 1/3 of the picture can be drawn before you get to 2 pi.
Yes.
That means I need to have 6 pi long to get the whole picture. I get 1/3 of it, 1/3 of it, 1/3 of it. So let's look at it. -5 cosine of 1/3 x.
1/3 cosine.
The period comes from the 2 pi divided by the 1/3. And that's where we got the 6 pi
That
from.
was 6 pi, yeah.
So every 6 pi radians, it takes 6 pi to draw even one. Do another one. Okay, it's getting uglier. What's my amplitude?
2.
What is it?
2.
Plane 2. Not worried about that negative?
Nope.
But I'll tell you one thing. Remember the sine curve usually starts at 0 and goes up? Not this one. What do you think it does?
It goes
Say it again.
up to down.
Nice job, Hema. It starts here at 0 and it's going to go down because of this blasted negative there. All right. How about the period?
4 over.
Okay, let's do the math though, because I don't want you to don't run away with it, Jonathan. Let everybody think, because it's fractions. 2 pi divided by 4/3 is the same as 2 pi times what? Think reciprocal.
3, 4.
3 over 4. So what is 2 times pi times 3 all divided by 4?
What's 3/4 of 2?
That's too complicated. What's 2 times pi times 3? What's 2 times 3?
Oh, 6.
So isn't that 6 pi divided by 4? And then I could reduce it?
Like simplify or just, oh, no.
Yeah, let's simplify it to make it easy to understand.
3 pi over 2?
3 pi over 2, which is a 270-degree angle. It takes 270 degrees instead of 360. That means it still finishes faster than the original.
Can I go now?
Yeah, did you get your pass?
Yeah, I'll do your notes when I'm you, man.
I am recording, and you could always rewatch it.
I don't think he has the time to do that either.
All right. So, all right. That's all. We did a lot of looking at, so I hope we don't have to. Now, the next page.
So wait, you're recording right now?
I've been recording.
All right.
They can hear you talk?
Huh?
Yeah?
Yeah?
Yeah.
Hello, other classes of Mr. Cartwright. Follow me on social media.
Yeah, follow them.
You guys don't know who I am. Yes, though.
Yeah, we do.
They don't.
Soccer fan.
They don't. They don't.
All right.
On with the lesson.
Here we go. Identify the amplitude period, then graph. All right. So I'm not going to get the best perfect graphs that the author gives. Matter of fact, I don't even think I'm going to fill the whole grid every single time. And I don't expect you to either.
Good enough for the government? Good enough.
Yeah, exactly. So what's my amplitude for number 5?
That would be a 2.
Natalie, what do you think? Yeah, you think right. Yaretsi, help me out with the period. We have never had a period of a 1 yet.
It was 2 pi
What's the formula?
Oh, they're only 2 pi over,
I like that. 2 pi over what?
over 2?
No.
Remember,
One.
I
O-
thought it was-
over the number, the letter B. What is B in this problem?
Oh, 1.
Oh, 2 pi over 1. What is?
One, yeah, I was-
So that means the whole picture finishes in 2 pi, right? But the amplitude is 2. So what I want you to do is, it's a normal sine curve, right? Except for the amplitude is 2. That means up at 2, I want you to either put a light dotted line at 2 to remind you that that's as high as it can go.
And -2.
And then at -2 is the lowest it can go. I want you to do that on your paper. It helps you out a lot. And then, since we're starting at 0 and going to 2 pi to finish it up, at least let's look at what happens from 0 to 2 pi. So 0 is here, 2 pi is here. So put another dotted line here to say that my one cycle is going to finish up in that amount of time. Now, you want to know another secret that I tend to do to graph my sine curve? What I do is I take 0 to 2 pi, and I try to divide this rectangle. There's a rectangle here. I try to divide it into 4 equal pieces. So if I go from 0 to 2 pi, what would the middle be?
Up high.
Okay, so what I'm going to do, I'm going to drop another invisible mark here. What would be between, now let somebody else do this one, because it gets harder, Jonathan. From 0 to pi, where do you think the middle would be?
Wait, how is that harder?
Half of what?
Half pi.
Nice. Where would that be on my screen here? Okay, I'm gonna move. You tell
2, 0.
you tell me. I'm gonna start drawing. You tell me when you think I can stop.
Is it right there?
Oh, perfect. So right here is the middle of that one. Where's the middle of the other one? Oh, right here, right? So here's what I do. If you know you're dealing with a regular sine curve, which I am, I divide it into 4. Did we say this one's going to go up or go down? We didn't say, did we? But it is up. So here I go. I'm going to go up, and at that first tick mark is where I max out.
Oh, okay.
Then the next tick mark is where it comes back down to earth. Where do you think it goes on the next tick mark? To what value? To the 2 up here or down here?
It goes down.
It's got to go down because I went all the way up.
Oh, that's
Now it's got to go to the bottom of the box down here. And then where does the last tick mark at the end go? Exactly. There's my picture.
That makes sense.
Now, the author likes to show off, and what the author does, the author fills the whole grid. So the author would have to also go from 0 to the -2 pi. The author would cut that in half, cut that in half, cut that in half. And then so I know I have a dot here, and I have a dot here, a dot here, a dot here, and then a dot here. So you see that? So what I've done is I replicated the picture. There's the full picture. I would like to see 2 cycles if possible. All right, that was the easiest one.
About the question from before, where people said the graph goes up because it's positive. Because if it's negative, it goes down.
It would. Okay, let's do another one here. Okay, I can tell something funny is going to happen. This is not as easy as what we did a second ago because A is a 5 and B now is a 1/2. So keep that in mind. So what's my amplitude?
5.
Okay. How fast can you do the period?
Very fast.
Okay, you keep it to yourself. I want other people to have to think.
6 pi?
No, it can't be 6 pi.
You're close. You just multiplied wrong, right?
You probably multiplied wrong.
Reciprocal 1/2 times 2.
So it is 4 pi, yeah, because for those that don't know, pi would be 2 pi divided by a half, which means 2 pi times the reciprocal, the bottom fraction, 2 over 1, which is 4 pi. Which really is bad because you guys, I want to do the picture to the right, 4 pi to finish the picture. And so you're going to say, I can't do that, and you can't. So just, you may not be able to do the whole picture right now, but watch.
Let's just do one.
If I start at 0, it ends how long later?
2 pi. No, wait. It ends at 4 pi.
If I start at the 0 where sign starts, by the way, it ends at 4 pi, but this only gives me 2. So I need to extend this to approximately here to 4 pi.
We know the top wave ends at 2 pi and the bottom wave ends at 4 pi, forming a singular
Does it matter if we go like,
period.
if we start like going up or down?
Well, it depends on what x value you're at. Oh, you mean, how high is it going to go?
5.
Well, then I better go up to my 5 and make my line here, right? The invisible line. And where's the other visible line going to go?
Negative 5.
Negative 5. So if you had unlimited room on your paper like I do, so you can just ignore me for a minute and see what's happening on the grid that she gave you.
So just a question. So you have to always start going from positive and negative.
Well, this one is a positive 5, so it is going to go up.
But if it's a negative 5,
Then it's going to go down.
it makes sense, right?
But yeah, but let me see. I know you can't do everything I'm going to do because I added room here. I need to divide this into 4 regions. So between 0 and 4 pi is
2 pi.
2 pi. So unfortunately, you're only going to see half the picture in that box.
But we get it because the mirror.
You get it, you're right. And then what's between 0 and 2 pi?
Pi.
There's my other tick mark. What's between 2 pi and 4 pi?
3 pi.
3 pi. And even if you don't know what it is, you know the tick mark's about there, right? So watch. We start here, 0, 0. It's going to go all the way up till I get to the top, and that's going to go up to the 5 here. Next tick mark, it goes where?
Goes to 2 pi.
Stays here. That's as far as you can go. Here's all you can graph because you guys don't have a good paper, right?
Yeah.
Now, I can keep going and say, what happens to the next tick mark? Where am I at?
It goes down to
I'm
negative 5.
I'm at the floor. Where am I at 4 pi?
And then you go back up.
I'm up here. So I'm able to draw the full cycle there. But the best you can do is draw half a cycle, and then I can draw the other half going the other way, can't you? Would that be the other half going to the left?
Yes.
Now, if you had more room and you wanted to draw the cycle all the way to here, fine. If you don't have room and you want to stick it to what she gave you, then just do that graph. Easy or hard?
Easy. It's a good concept.
Ma'am. Yes.
Good concept to start.
But it's good thinking, though, isn't it? I mean, this is something you've never done before.
It reminds me of when we did like the different powers.
Yeah.
Power of 3, and then you know it's positive because it goes.
Yeah, you got some things. All right, now look this one, I hated the graph. You'll see why.
Oh no. It goes down.
Well, that didn't bother me so much. I almost forgot the negative before. That's not what bothered me. What bothered me is that there's a 4 here. So my amplitude is how much?
3 over 2.
3 over 2.
And what is that as a decimal?
About 1.5.
It is 1.5, 1.5.
Sure, let's do 1.5.
So keep that thought. Period. Period will be 2 pi divided by the 4. So how long will it take to graph one cycle?
Pi over 2.
Are you serious?
Wait,
The whole picture in pi over 2? You're right. And I don't like her graph. I don't like her grid. Because where's pi over 2 at?
4 pi, right? You simplify it, it's just 1 over 2 pi. That'll just be pi.
Huh?
I'm thinking, hold on.
Well, let me do the 1.5 first. My invisible horizontal lines. 1.5, here's 1, here's 1.5. True?
Oh God. Oh
All the way here.
God.
And then here's negative 1.5 down here.
May God have mercy on us all.
So you see these tire tracks that I have? The whole picture has to be between these two yellow lines. Okay, so if that's not bad enough, now tell me about the period. If I start at 0, because I'm allowed to, and it's negative, right? Hema saw the negative, so it means it's going to start down here, right?
Yep.
Now, when is it going to end?
Pi over 2. The distance,
Well, where's pi over 2
the
at?
distance between 0 and pi. Like,
How many tick marks is that?
2 tick marks.
Yeah, here's a tick mark.
It'd just be 2 0.
It's 2 of those. It ends here. How am I going to get the whole cosine picture there? I mean, I'm lucky. I can zoom in.
Then you divide it again.
I can zoom in. Watch this.
Oh god, yeah, that's weird.
I need 4 tick marks. So there's the middle, there's the middle, there's the middle, and here's how cosine works. Watch. If I'm starting down here, the first tick mark is where I cross the axis. The second tick mark is where I reach the maximum right here. The third tick mark is where I reach the axis again. The fourth tick mark is where I'm at the bottom again.
Ooh.
Well, look what it looks like in real zoomed in.
I see the issue now.
You see the issue? Good luck, guys.
Dear,
You must have eyes of an eagle to be able to do that on your paper. Now, she actually filled the whole thing. She went and graphed another cycle, another 2 pi over. 2 pi plus 2 pi is pi. So here she goes. She goes and she goes, wait, I did it wrong.
wait, what?
Already messed up.
Because you're supposed to go down.
Yeah, I can't do it unless I drew my tick marks. So I literally have to say, okay, I need another tick mark here and another tick mark here. That means I have a dot here, a dot here, a dot up here, a dot here, and another dot down here. So they're very close. Now that I have all my dots, I can actually pretend to know what I'm doing.
I realized what this was.
You see that?
God.
If I do one to the left just for fun, that would be out here, it's stopping out here. That's a negative pi over 2, right? But again, I can't do it unless I make my tick marks. So I got, that's cut in half, cut in half, cut in half. And again, I'm starting at the bottom, so there's a dot here,
This won't be on the test.
dot here.
This level of precision.
Well, I'm pretty lenient. There. Good enough. I'm not filling any more in.
I mean, like this type of problem on the test, like it really stupid.
It could be, but the next lesson is even worse because she wants us to start moving our sines and cosines left and right and up and down. And I'm going to show you a better way
Okay.
and I can do it for the next problem if you want, just so you can see what I'm going to lead you to. Yeah, I can do this one. Negative sine of 8/3 x. Y equals negative sine of 8/3 x. This is how I usually teach it, but I've never used these materials before. This is the graph paper I give everybody. Watch. You're going to be amazed.
But sir, that's just line paper. Or not anymore.
There's my graph. Okay? And you're saying to yourself, well, how do I graph it? Well, if this is my 0,
And that's your one.
then, and the amplitude here is what? What's my amplitude?
One.
It is 1.
Is it 1 or negative?
Absolute value.
One.
Always the absolute value. So if this is my 0 on the y value, this is my 0 on the x, how high will it go?
One.
How low will it go?
Negative
Okay, you're doing good. Now, let's talk about period. What's period?
2 pi times
2 pi divided by 8. Was it really 8 over 3?
8 over 3.
That's ridiculous. And nobody's going to do that for real. And that equals to is 2 pi times
3 over 8.
3 over 8, which is
6 pi over
6 pi over 8,
8.
which is,
3 pi over 4.
okay, at least I know pi over 4 is a 45-degree angle. and I have 3 of them. So here's what I do. Since this does not move left or right, starts at 0, right? Does that mean my first point is definitely going to be here, and the last point is going to be here, right?
Also, the graph goes down.
And so the value at the end is going to be exactly what you said, 3 pi over 4. Now watch this. Cut this in half, cut this in half, cut this in half, and I'm ready to show you the dots. The sine curve, does this open up or open down?
Down.
Down.
There was a negative. So that means first tick mark, it'll be here. Second tick mark, it has to be here. Third tick mark has to be here. Fourth tick mark is here. Here's your picture.
Oh, nice. Just like the parent, but the numbers on the graph are really misleading. So
That's the secret. All graphs will look the same. It's what numbers you put on the axes that tell you what it is.
that's smart.
And then if you wanted to, you could just replicate another cycle and do the same thing.
So we don't have to draw a minuscule graph.
Well,
like the point ones.
Yeah.
0 ones.
There, well, that was ugly. But you could also draw 1/2 going this way if you wanted to.
Yeah.
So you could go either way. Now, I used to teach it where all I give you is naked grids and you put the whatever numbers you can find. And all the pictures look the same. None are skinny, none are fat, because I don't really care about the actual look on a calculator. And so in this case, I can take this skinny one and make it look normal, you know. But
Relabel the graph.
how would I do it here, that same problem? You said amplitude was 1, and you said the period was 3 pi over 4. So you want to hear my cheater method on this grid?
You just divide pi by.
Well, I got to figure out where 3 pi over 4 is. And that's 3 times 45 degrees. So what is that?
Not very nice number.
Well, you got a calculator.
What did you say?
3 times 45.
135.
So we know from here to here is 180, right?
Yep.
So you want me to go to where?
35.
So from here to here must be 90, right?
Yep.
So somewhere between here and here, maybe?
Wait, no. She said 135, right?
Yeah.
It would just be the center
Wait.
because 90 plus 45 is 135.
Oh, the center? 90 plus,
Between 90 and
Let's
5.
talk about that line.
oh, 90
The
plus,
line is specifically 135.
where, in the middle of this?
Yep.
In between the
Exactly
pi-
135.
Okay, so it's stopping here?
Yeah.
Okay. So I'm going to zoom in on this here.
You don't-
Or you don't have to zoom, but there's my magic space, right?
All right.
Ignore all the lines. Cut this in half, and it's kind of hard to cut in half because there's only 3 of them. So cutting in half looks something like this, right? Cut this in half looks like this. Cut this in half looks like this.
Oh, no, God.
And then so we still were going, how high were we going?
One.
Okay. So if I'm going to a 1, it was a sign, right? Upside down sign. Here are my dots. So I got to go level here, and here is my straight lines, right? Here goes.
Ooh, that's annoying.
Starts here, 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 and here. There's my picture. Yes. So there's one cycle. It's close enough for government work.
I'm just going to draw one.
You want to go the other way? It was like, to me, like almost 2, yeah, right. So I could just go, say 1, 2, almost 3 lines, it seemed, here, almost 3 lines. But it's just an estimation. All right, I don't know why she gave us the ugly ones. Number 9, what time is it? I want to know if I got to go to, yeah, okay, we got a lot of time. Let's do this one purely with a calculator
All right.
to show you that your calculator can help you out. Now, mind you, this paper goes up 4, up 5, down 5, to the right 2 pi, to the left 2 pi. So I'm going to turn the recording on. So you could go back to you could go and plot your points. But it still helps to do what we did before. It helps to go 2.5 up and 2.5 down with your dotted visible line, just to help you out. And it also helps you to figure out, we didn't do it. 5/2 is my amplitude, which is 2.5. My period for this problem was what? 2 pi divided by 2/3 means 2 pi times 3/2. Don't the 2's cancel? So what's left? 3 pi. So I know her grid is terrible because it only went to 2 pi and a little more. I technically need to go all the way to about here to get to 3 pi. That would help me a lot. Now watch me. I could use my calculator and get more values, but here's my real cheater method. I know I'm going, and you guys can do the same thing because this is also on your paper. Cut this from 0 to 3 pi into 4 pieces. So roughly eyeball it. Where does the middle look like it? Tell me when to stop. Tell me when to stop. The middle.
About there.
No, a bit further.
Right
there.
Tick mark.
This one.
All right, give me a middle between that one and the 0. Tell me when to stop.
Let's see.
Somebody else do this one. My brain's not
About
working.
there. No. Is it?
No?
No, it's not. I don't think it is.
It's close.
It's to the tick mark to the left, right?
That's too far now.
No,
I like where you had it before.
Yeah.
No, right in the middle between that and the.
I'm going to keep it there. It's close enough for government. And the other one?
Also, to put it
About
in
here?
context, that's
So why am I doing that? It's going to be another negative cosine means it has to start at the very lowest at 0. Where's my various lowest? 0, negative 2.5. And that's where my calculator showed me. The next tick mark has to go through the x-axis right here. Boom. The next tick mark has to go all the way up to the very top. Boom. The next tick mark has to cut the axis again. So unfortunately, that's all you're going to see on this paper. You're going to see this. That's all you're going to see if you only stopped where she drew. But I got a little more room here. Boom. I finished the whole picture.
nice.
And so if you go the other way, the same thing. I need a little more room to get. If I just duplicate what I have here, it's going to be something like that, I think. Yeah, because I would need more room to finish it up to go here. I would need more room, but that's pretty close. All right, let's go to, and you can use your calculator. There's nothing wrong. I can show off I did finish that problem, but I didn't record my talking. I'm finishing that one up. That's okay.
Where are we on?
Tangent.
Oh, the next one.
Yeah, I should have, all right. So now tangent. Now this is your parent function for tangent. Here's what I want you to notice, guys. That it goes up forever, goes down forever in many different places. And where they're going up are called asymptotes, and they're exactly in the middle of each other. So I'm going to draw one here. See, what's happening is this thing is coming down, and it's going to be always wanting to get close to it. And as this asymptote is up here, you see how the function's getting close to it?
They're just not gonna do
Undefined.
It'll never touch. That's where it's undefined.
Vertical asymptote.
Yes. Yes.
Yeah, you guys can have fun.
Yes.
I couldn't see it. Can I go to the restroom?
Didn't you already go?
No.
No.
He went to get his water. That's.
That was good enough.
That was like a
You should have gone.
class.
Yeah.
You should have went then. You were already outside the room.
That was at the very beginning.
There's no reason you should be leaving my room twice. Hurry up.
When I was messing with my calculator and putting those things in, like cosine of x and sine of x, I saw them as waves, and then I was like, tangent must be a wave, huh? And then you see this.
For the trace, you go to the menu again, and then it's option number 5, and it says trace, and then you just move.
That's after you graph it, you hit menu again,
And then you click.
and that's the same menu you went to change the window settings?
Yes, the menu button right here.
Menu 4?
Menu 4 was for window, menu 5 is for trace.
Oh, wow. I guess I could learn that calculator if I could see it. All right, so there's a whole bunch of vertical asymptotes, but I want to show you the two things I need you to understand if you learn nothing about tangent. The parent function y is the regular tangent of x, meaning it's positive. Here's my basic thought process. I'm going to tell you up front that the two asymptotes, one's at pi over 2 to the right, and one's at negative pi over 2 to the left. And that's going to be a vertical asymptote. So I want you to memorize that, guys. And so the one period is the picture you draw between those the dotted blue lines. So I know it goes through 0, 0, but since it's a positive tangent, it has to start from the bottom, and it goes up, curves into the 0, 0, and then the asymptote again makes it straighten up. See that? That's your positive tangent. If you've learned nothing else today about tangent, I want you to know that's tangent coming from the bottom. And FYI, if you go another pi over 2 this way, you make another asymptote, you can actually draw the picture again. Or at least you can draw, not a pi over 2, you have to draw,
Just do a pi.
huh?
It'll just be a pi.
A pi? Yeah, you got it. What's a pi? From here to here? Yeah, that would be at pi. And then you could draw another one. And so
Wouldn't these oddly look
you're getting another, so it repeats itself. Okay? So here is y equals negative tangent of x. Again, if you've learned nothing else, I want you to see my one period. From a pi over 2 again, negative pi over 2, vertical asymptotes. What's the difference? It flips. It comes from the top.
to the, yeah.
It's on the asymptote, coming from this way, curves in, hits the 0, 0, curves out. There it is. So that's a terrible picture, but you get the point. That's the negative tangent. Okay? And of course, there's going to be more of the same pictures following the asymptotes and more and more and more. Okay? So what do we have to put here? Given f of x, here's an a, here's a b. The period of tangent, Jonathan, you already figured it out.
Probably. Oh.
How much distance is there between this asymptote and this asymptote? Half a pi this way, half a pi that way. Altogether is? It finishes in pi. So if you have a number in front, though, like a number b, our period is pi divided by b, not 2 pi. Why is it pi? It takes a pi to get the whole picture. Only 1 pi gets the whole picture. And the vertical asymptotes are always located at, well, the author says that the function is odd, meaning that if you go to the origin, like I have here, odd function means that if you plug in like an answer like pi over 4 right here, and then you plug in the negative pi over 4, you're going to get different answers. One's going to be up and one's going to be down. So if f of x, or I shouldn't say f of x, f of some number will be the opposite of the other number, opposite of f of a negative
Reciprocate?
a.
No.
Well, they're a's. Those are just a's. I'm just saying that the y values will be opposite of each other. That's why it's called odd. But here's the important thing. Multiples of, what was it? Oh, it's actually half of pi over b. 1/2 of pi divided by b. Or in other words, I like to call it pi over 2b. And again, they always use those absolute values for b's, so feel free to put your absolute value there. In other words, every time you have a multiple, like if you can count by that number and keep making new ones, that's hard.
You know, sir, why do they behave like third degree,
They're what?
They, like the tangent lines, they behave like the third degrees. Like it comes from the
Oh yeah, you're right.
They behave like
I never thought of that.
And cosine.
Yeah, you have homework. All right, let's try one by hand here. This is a regular tangent with a 4 on top. Why is there no such thing as an amplitude?
Undefined.
Why?
To infinity and beyond.
And yeah, it goes up forever. It goes down, so that's why there's no amplitude. But period will be pi divided by b. In this case, what's my b? So it's pi.
Just pi.
That means you got to take half of that starting at 0. You got to take half of that and go to the right.
And it's positive.
That's right here.
It's just the normal default parent third degree function.
Oh, it looks like the one I just did.
Yep.
So between those two numbers, pi over 2 and negative pi over 2, you need to understand that that distance does add up to pi. If you take a negative pi over 2 distance, take the absolute value of that distance, it's pi over 2, that does add up to pi. So that means there's my dotted lines. There's my dotted lines. Those are my vertical asymptotes. Please know those are vertical asymptotes. And so you said it was a regular tangent, right?
Yep.
Positive, starting from the bottom. So I go to my asymptote, start from the bottom. Here goes, up, scoot over, touch it, up, and put arrows there to let the person know. Now, you want to really do good? I need to go another distance of pi over. So it took 1, 2, 3, 4 blocks. So 1, 2, 3, 4. Here's the other asymptote here. And then the middle part is going to be here. So pretend it's the same thing. Start coming from up, go up, cross over there. There's two periods. I can actually do a period on the left. 1, 2, 3, 4 would be where another vertical asymptote is. Between those two asymptotes is where the dot goes. And here goes. Isn't this so exciting? Up, curve, up. There it is. There's 3 beautiful periods of that tangent. All right. What if there's a B now? Uh-oh. And this has a negative. So my period now is going to be pi divided by what? 1/2. Well, what is pi divided by 1/2? It's pi times 2. 2 pi. That means I need to start at 0 and go pi to the right and pi to the left. Why pi? Because both pieces have to add up to what? 2 pi. So I go pi to the right. There's my asymptote. Go pi to the left. There's my asymptote. Start in the middle. Do I start from the bottom or do I start from the top?
Oh, it's from the top.
Why? It's a negative tangent. Here goes from the top. Pretend you're writing the asymptote. Come in, hit the 0, 0, and boom. Look at that beautiful tangent. Now, unfortunately, it took me 1, 2, 3, 4. If I go 1, 2, 3, 4, I only have room to do half of a picture on this side. Boom. There it is. And on this side, 1, 2, 3, 4. I only have room for a half of a picture, and it'll be this piece here. Boom. All right?
Our time is limited.
Well, it's fine. I did 2. I expect you to do 2 in your homework, so it's fair. You want to do one with the calculator real fast?
No.
Oh.
You know, sir, I'm not gonna lie. The homework isn't that hard. It's the step.
I'll tell you what it is. It's definitely all of that much in tangent. Matter of fact, most of you will probably use your calculator anyway, but yes, you will. Page, and on that, the last page, I don't want you to do all those tangents. I only want you to do the two. So I'm going to cross off 11 and 12.
Can I cross that out too?
Yes. You don't have to do 11 and 12. You don't have to